Hi there, and welcome to 272analytics.com's tutorial on how to carry out a one-way analysis of variance, also known as an ANOVA, in SPSS. In order to do so, I've gone ahead and created a simple data set for you here. It consists of 4 teachers and scores associated with them. Notice that there's more than one score value per teacher. And what I'm assuming here is that each teacher teaches multiple classes, and each class has an average score of the students in that class. And what we might want to know, as for example the school's principal or someone like that, is are the teachers grading roughly the same? Might there be a teacher who's grading a little bit more, a little bit less strictly than the others? Might there be an effect of variation in teacher on the score? That's a great problem for ANOVA to solve. And here in SPSS, we can actually analyze that here by going to Analyze, Compare Means, one-way ANOVA. And I've gone ahead and put these variables in for you, but I'll take them out just so you can see that this is the way it'll look when you enter it yourself. Teachers are what's called a factor here. They're going to be the grouping variable, right? So that's the category. And what we're interested in is variation in this continuous variable of class score. Now we're going to want to do a couple of things here. I've highlighted some post-hoc comparisons, which I'm not going to explain right now. We're actually going to talk through them after we get them. And I've picked a couple of options, descriptive and homogeneity of variance and a means plot being the most important. These are what we'd need in a very simple ANOVA. And I've gone ahead and run this model for you. Okay, it doesn't do the best job of fitting on my screen, but in just one moment we'll expand it and then we can have a look at it and see what it means. So the first thing that SPS gives you is the set of descriptive statistics. And so we have these 4 teachers. And by the way, later I'll just show you my coding so you know that these numbers didn't come out anywhere. I already went ahead and labeled each teacher number with a teacher name. What do we have here? We have their means. And very importantly, for something like the ANOVA, we have the 95% confidence interval for the mean. Now I'm going to give you a number, and that number is 87. I want you to observe that the number 87 falls between the 95% confidence interval for each of these teachers' means. So there's at least one score, and there's a continuum, there's actually a couple there which you could work out for yourself, that fall in every single teacher's 95% confidence interval. Now that strongly suggests that there's kind of an overlap in how these teachers are grading, and we're going to look at that more closely in a minute. And we'll come back to this test of homogeneity of variances in a moment. The key figure here in the ANOVA window is the sig, or the p-value, which is 0.415. Now if that's over 0.05, it tells us that there is no effect of teacher on class means, or expressed another way, it doesn't seem as if the students are getting different scores based on which teacher they have, right, in the aggregate. Now we did a whole bunch of these post-hoc comparisons, and what does that mean? Firstly, let's note that the assumption of homogeneity of variances was not met. That's why I picked Tamhane here, because if you remember the SPSS window that was associated with the post-hoc options in the ANOVA, Tamhane was one of the ones where there wasn't homogeneity of variances. That's why I picked that. Now if there was, I would have looked at something like Tukey HSD, which is the most common, most popular post-hoc test when that assumption is met, or I would have looked at Bonferroni. Now this is the same kind of material, so I'm going to ignore the Tukey and Bonferroni, scroll down here to the Tamhane and walk you through it. I want you to observe that when we do this post-hoc test, we're comparing each teacher to every other teacher. It can be the case that an entire ANOVA is not significant. However, there happens to be one sort of pairwise comparison that is significant, right? And so you don't stop just with the ANOVA. You always conduct a post-hoc test so you can see, look at which teacher, in comparison to which other teacher might have a significantly different mean. So I really want you to think carefully about that. It's the key to understanding a lot of what goes on in an ANOVA. An ANOVA can be significant, but there could be some particular comparison that you're interested there that is not significant, or the other way around. The ANOVA could be non-significant, but there's some comparison within it that is significant, and that's what you're interested in. Now let me highlight these p-values for you here with my mouse, if you can see those. If we scroll up, we'll see that column sig. And what this means is because none of these numbers are, below 0.05. There's no difference between any teacher and any other teacher in terms of their mean scores. So another way to kind of see that, and the Tukey HSD generates this for you. It's called a homogeneous subset. All of the teachers fall in the same subset. Now, if they didn't, you'd see like one column here, then another for the teachers who fit another subset, and so on and so forth. The means plot here isn't super useful, but I deliberately created it for you because if you go just on the basis of the means plot, you cannot see the confidence interval. You don't know anything about the distribution, so you cannot look at this means plot and assume that, for example, Brown's means were significantly higher than Henderson's. So this is actually kind of misleading. It's something that it's good to have if you just you want to get a quick view into what the means are, but you're going to have to generate something that has a confidence interval to actually understand that better. And one way to do that, we can go ahead and do it right now. We can do graph, we can go to chart builder, okay, and I've actually pre-populated this for you. We can put teacher down here and class score here and go ahead and generate a box plot, which is a lot more useful here because you really get a sense of how all these scores overlap. So if you look at the lower whiskers and the upper whiskers for each distribution, notice that if I draw a line right through here with my mouse, just about, there are places where all four of these teachers overlap with each other. And basically that's a visual way of confirming what the ANOVA already told us, which is that there is no significant effect of teacher on variation in the score. So that's a one-way ANOVA. ANOVAs do get more complicated, and then you can get into the MANOVA, which has multiple dependent variables, and then you can get covariates in there. A great way to begin, though, is to just do a very simple ANOVA that has two variables and just try to understand the intuition of what we're doing. I mean, essentially, we have one variable that's categorical, which in this case was teacher. We have another that's continuous, that's a number, that's scores in this data set. And what we wanted to do was we just wanted to understand differences in means based on our sorting category, which was teacher. And doing this analysis, we kind of found out that you can't just look at the raw data and or calculate a mean or something and assume that one teacher's scores are different from the other. You need inferential statistics. You need an ANOVA, and in this case, you needed a Posthoc test too, to kind of get that more valid and statistically sophisticated insight into what the means differences were across these different comparison categories. I hope this tutorial was helpful to you, and I would like to invite you to visit 272analytics.com for access to all our free statistics tutorials in Stata, SPSS, R, eViews, and Minitab. Here at 272analytics.com, we provide data consulting primarily to graduate students. Therefore, we work very closely with you in order to perfect your Chapter 3 and Chapter 4. That means helping you design surveys, getting your data input, assisting you with fashioning appropriate research questions and hypotheses, getting your data, extracting them, transforming them, cleaning them, putting them through analysis, interpreting them, explaining them to you, so that at the end of the day, you know exactly what story your data tell, why they matter, what they mean, in a manner that lets you write a perfect Chapter 4, following a perfect Chapter 3, and lets you defend your dissertation or thesis with complete confidence. We provide ethical consulting. It's not a writing service, so you will be responsible for taking our blueprint, our assistance, our consulting, and transforming them into an appropriate academic project for yourself. I'd also like to remind you that we provide the same services to undergraduate students who are working with quantitatively oriented assignments. Thank you so much for listening, and have a great day.